Remember that time we talked about rectilinear motion, and I gave you S of t, and S of t represented the position of a particle along a curve, and then we wanted to find the velocity, and the way we did that is we took the derivative, and then we wanted to find the acceleration, and the way we did that is we took the derivative again. Well, now I'm not going to give you S of t, I'm going to give you V of t. And in order to find distance or something along those lines, I'm going to have to go backwards. Take the antiderivative, the integral. Let's talk about displacement. Imagine you're standing right there, you jumped 3 feet in the air, and you landed right where you started. How far did you go? Nowhere. That's displacement. If you hit a baseball up in the air and it goes 50 feet up in the air, but your friend 10 feet away catches it, that ball only went 10 feet. The way we find displacement in calculus is we take the integral of the velocity function, and your limits of integration will be your starting time and your ending time. Distance is a completely different animal though. In the jumping problem, if you jumped 3 feet up in the air and 3 feet down, you went 6 total feet. In that baseball problem, if you hit the baseball 50 feet up in the air and it came down another 50 feet, that ball traveled 100 total feet. Well, how do you calculate that? Well, the first thing you do is you take the velocity function, set it equal to 0, find the critical points. After you find the critical points, you make a velocity line. You plug in numbers bigger than those critical points, smaller than those critical points, and find when the velocity is positive and find when the velocity is negative. For the intervals that the velocity is negative, you are going to take your velocity function, throw a negative in front of it, and integrate using those intervals as your limits of integration. For the areas that they're positive, you take the integral like you normally would, and use those intervals as your limits of integration. Once you have 2 or 3 or however many numbers that you have, you add up all of your distances. You should get positive numbers every single time. You add them up, and that is your total distance traveled. Let's give it a shot. Alright, boys and girls, last section we're talking about rectilinear motion once again. But instead of being given a position formula, we are being given a velocity function. And our job is to find distance and displacement. Now imagine we have a car. We take that car and we back it up 10 feet, and then we pull forward 8 feet and we end up here. Okay, if I back it up 10 feet and pull forward 8 feet, I have a distance of 18 feet traveled, even though I'm only 2 feet from where I started from. Displacement is that 2 feet. Displacement says I started here, I ended here, I traveled 2 feet. Okay, and the way we find displacement is we just take the integral of the velocity function. And whatever time we started at, we usually call it t sub 0. Whatever time we ended at, t sub 1. That's all we do. If I want to find distance, that is I go back 10 feet and then I change and then I go forward. So I have a negative distance and a positive distance, and I have to find a way to combine the negative and the positive without canceling each other out. So what I do is I take the integral of t sub 0, the first time we started, to the end time, and we take the absolute value of the velocity function. Okay. So I'm using this smaller pen because my Sharpies are starting to die out and I'm going to need the space. Let's start out with displacement, the easier problem. Displacement. What I do is I take the integral of the velocity function. In this problem, I start at 0 hours and end at 3 hours. So I'm going to take the velocity function, which is 2t minus 4 dt. I take the integral. The integral of 2t is t squared. The integral of 4 is 4t. And my limits of integration are 0 and 3. I plug in 3. So I have 3 squared minus 4 times 3. Minus, I plug in 0. 0 squared minus 4 times 0. I do the necessary math. 9 minus 12 minus 0 minus 0. 9 minus 12 is negative 3. Minus 0 minus 0 is, I think it's 0. And negative 3 minus 0 is negative 3. So what this means is my displacement is wherever this guy started, wherever my particle or whatever it is started, in the end, they are back 3 miles. I know this is miles because the original problem says the velocity of the particle is given by the function vt equals blah, 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 miles per hour. So this displacement is 3 miles, and we'll say back in the reverse direction, whatever that means. Backwards, downwards, in the negative area. That's what displacement is, 3 miles back. Now, if I want to find the distance, that's the harder part. It's a 3-step process. I first have to find out where that velocity function is positive using critical points. Okay? Critical points, which means I take my position function, I take the derivative of it, which is the velocity function, and set that equal to 0. So step 1 is you take the velocity function and set that equal to 0. 0 equals 2t minus 4. Add 4. Divide by 2. And t equals 2. What that means is you remember how I said that if I have a car going backwards and then forwards? Well, that change from backwards to forwards or forwards to backwards happens at 2. So my particle is moving in reverse and then moving forward, or moving in forward and then reverse. Either way, it happens at 2. My job is to now find out, is it going backwards first and then forwards, or forwards first and then backwards? So I make my line thingy, and I'm using v of t, my velocity function, because I need to find out when the velocity is positive or negative. That's step 1. Find where the velocity is positive or negative. Things change at 2. So I can plug in 0 because it's easy to plug in. I can plug in 3. And I plug this into the velocity function. Okay, I'm going to plug in 0. V of 0 equals 2 times 0 minus 4. I'm plugging it into the velocity function because I care about when the velocity is positive or negative. And on the left side of 2, it's going to be, in this case, negative. So I'm going in reverse here. It's going to be important. Okay, if I plug in 3, I have 2 times 3 minus 4, which is positive 2, positive. So I start out, just like in the car problem, I go backwards and then I go forwards. Okay, now I'm going backwards. I start at hour 0, and I'm going backwards for 2 hours, and then I go forward for 1 hour between hours 2 and 3. So these are the 2 integrals that I need to set up. The 2 integrals that I need to set up. Let's focus on the negative. Boy, isn't that life, huh? I take the integral. Okay, and remember, if you're setting up your integrals, the first thing you have to make sure that you do is, in this case, I'm just going from left to right. My negative happens between, remember, my distance is 0 hours to 3, so my negative exists between hours 0 and ends at 2. If it's the negative that I'm focusing on, okay, if it's the negative velocity, I have to use the formula negative v of t dt. In which case, the integral will be from 0 to 2, negative vt, which is negative 2t minus 4 dt. Or negative 2t, positive 4 dt. The integral of negative 2t is negative t squared. The integral of positive 4 is 4t. My limits of integration are 0 and 2. I plug in 2. Minus. I plug in 0. Negative 2 squared is negative 4. Plus 6 minus 0 plus 0. Four times 2 is 8. Oh, I like to have a good time. Boy, oh boy. Negative 4 plus 8 is 4. 4 minus 0 is 4. So between 0 and 2, I went backwards, but I traveled a total of 4 miles. Okay? So between 0 and 2 was negative. Between 2 and 3 is going to be positive. So I don't have to change anything there. I go from 2 to 3 of my regular velocity function, which ends up being what I did over here a few minutes ago. So I go from 2 to 3, 2t minus 4 dt. I already know that's going to turn into t squared minus 4t. Limits of integration are 2 and 3. So I plug things in. 3 squared minus 4 times 3, parentheses, minus 2 squared minus 4 times 2. Okay, so far it's almost the same as that, but not quite. So I know that this first guy is going to turn into 9 minus 12. Minus 2 squared, which is 4, minus 8. 9 minus 12 is negative 3. Minus 4 minus 8 is negative 4. 3 minus negative 4 is positive 1. 1 mile. The last step is you take what you got up here and what you had down here, add them, and the total distance traveled is 5 miles. Now this makes sense. Let's reassess what we did. Not so much the math, but the understanding of the problem. In this problem, this was my negative velocity. I went backwards 4 miles. I went forwards, because this was my positive velocity, I went forward 1 mile. I went backwards 4. I went forward 1. So I traveled a grand total of 5 miles, but I'm 3 miles from where I started from. Okay? So the math checks out, or at least the common sense aspect behind the math checks out. Oh boy. That was fun. You know, I would walk 500 miles, but this says I would walk 5 miles. It's a song. Look it up. All right, boys and girls, last problem. We are being asked to find the velocity of a particle whose velocity is sine t. Meters per second. I care about going between pi and 2 pi. All right. Let's understand what the sine graph actually looks like. Remember, sine is periodic. Okay, it goes up to 1, bottoms out at -1. Sine starts here, goes up, peaks out at 1, goes down, hits 0 at pi, keeps going down, bottoms out at -1, comes back up at 2 pi, and repeats. Okay, so it's a lovely graph just like that. So this is the velocity function. So I'm going to have positive velocities, negative velocities, positive, negative, positive, negative. My job is to deal with all of that. So let's deal with displacement first. Okay, where do I end up? Displacement. Remember, displacement is just the integral between pi, in this case, and 2 pi of my regular velocity function dt. The integral of positive sine is negative cosine, and that's between pi and 2 pi. All right, let's plug in 2 pi. I have negative cosine 2 pi, close it, minus negative cosine regular pi, cosine of 2 pi is 1, so negative cosine of 2 pi is -1, minus cosine of pi is -1, so negative cosine of pi is going to be -1, so 1. -1 minus 1 is -2, and what this means is my displacement is 2 meters back. Behind, back, down, you know, whatever means in the fake real world process that we're dealing with. Now I have to find distance. Distance. Remember, distance involves me dealing with negative and positive intervals. So step number 1 is I take my velocity function and I set it equal to 0. So I take sine t and I set it equal to 0. Now, according to the graph that I have up here, it's 0 a lot, okay? It's 0 at 0, it's 0 at pi, it's 0 at 2 pi. So t in this case could be 0, pi, 2 pi, and all the negative versions of it. But I'm not going to deal with negative versions because we're talking about time here. But every pi is going to be my time. However, I don't care about that. I only care about my interval of pi and 2 pi. So my critical points are pi and 2 pi. Well, that's funny. If my critical points are pi and 2 pi, and I make one of these line graphs right here, oops, sorry, my bad, pi and 2 pi, I don't care about anything over there. I don't care. I don't care about anything over here. I only care about what's in between pi and 2 pi. So let's plug in 1.5 pi. Okay? So I'm going to plug 1.5 pi into the sine function, which looks like that, lives right there. So I already know what it's going to look like, but let's just do the math anyway. Sine of 1.5 pi is equal to -1. Oh, how about that? So this guy is negative. So everything that I care about between pi and 2 pi is going to be negative. So this whole time our velocity is negative. The whole time we're traveling backwards. So I have a negative. Right now I'm doing distance, and I have a negative. And if you remember with negatives, okay, your job is to take whatever interval that this guy is negative on, and it's negative on between pi and 2 pi, which covers the entire problem, of negative velocity dt. Velocity is sine t. So I'm going to take the integral between pi and 2 pi of negative sine t. The integral of negative sine t is positive cosine t, and I care about pi and 2 pi. I'm going to take cosine, plug in 2 pi. I'm going to take cosine, plug in regular pi. Cosine of 2 pi is 1. Cosine of pi is negative 1. 1 minus negative 1 is 2, which means I traveled a total distance of 2 meters. So understanding the problem, I have a negative velocity only. So this whole time I've been traveling backwards, the whole time. And I traveled a total of 2 meters, so I end up 2 meters backwards, which means I traveled 2 meters, period. Period. That's a thing. Well, that's that. Bye.